How's it going? So, we are today going to be looking at a Sony FS-75 foot pedal, which I have here. And this, I think, the foot control unit was designed to be used with transcribers, so essentially tape recorders. And there's some limited amount of information available online. Looks like we've got a user's guide here. Oh, wait, no. So, mini cassette dictator / transcriber. Yes, use your feet with a dictator. Kick them, I guess. Anyway. So here's FS-75 referenced in here. Let's see if it actually gives us more information on... Okay, so here's the... this way, not this way. Well, I guess that's what happens when you have keyed connectors. Let's see here. Do we actually have a diagram of the FS-75? Right. Oh, here we go. Fast forward, rewind to the left, start/stop, and listen on the right. It is not supplied with this. But looks like it's a series of 3 switches inside of an enclosure, and today we'll try and both pin out what the pins are that get us those 3 different functionalities, because there are a lot of pins to look at, and we're also going to take a look at what the interior of the unit looks like. So let me switch over to the bench cam. Here we are. Oh, and I nearly forgot to change my stream title again. One moment, please. In the words of Big Clive. Again. Alright. Okay, a Sony... oh, jeez. It's not supposed to have an H in it. Sony FS-75 foot pedal switch. Yes, there we go. Alright. Alright, so here we have the connector. And here we have the foot pedal. So what we should probably try and do is tone this out to see what's connected to what. Let me just get my probes here. Come on. And get them hooked up to my, my multimeter here. So we'll start by just... There are numbers on these, so we'll start with ground at pin 1, or just hitting pin 1, and we'll see. So, obviously that's not an actual pin combination. Okay. Nothing on any of those. Let's lean on it. Seem like that's doing anything. Alright, so nothing between pin 1 and any of these. Let's try pin 2. Nothing yet. I'm guessing it's going to be a lot easier for us to just go in from the back here. See if we can't figure it out from the other side. Because I don't think this connector comes apart. I'm definitely not going to remove, well, I say that, but it looks as though there are these little hex pieces on the bottom here. Let me grab a nut driver and see if we can't actually just unscrew this. No, it's not 5, maybe a 4 millimeter. Oh wait, that's a 6. That's bigger, not smaller. Let's try the pliers on this. Indeed, it does unscrew. Huh. Let me get out a miniature socket and see if I can't use that. Looks like it's a 4 millimeter. Yep. Wrong handle. There we go. So sure enough, 4 millimeter socket will open an old Sony foot pedal connector. Good to know. Alright, so now there's a strain relief on the outside of this. Doesn't seem as though this is adhered, although I'm not certain. Except for by, age. Okay, so this is actually a soft jacket with pins that come in from the outside. Let me make certain I've got some more light on this. So this is a soft jacket with pins that come in from the outside. And we'll see if we can't pry back the jacket on both sides here. So I might have been able to do this without unscrewing those, it looks like. Interesting. I can't tell if the strain relief is actually bonded to the cable or if it's loose inside, if the cable's loose inside there. But either way, it's kind of immaterial as we're now inside of the connector. It looks like, ooh, this is an interesting one. Right, so the back shell here was held on by those 2 screws, but at the same time, looks like this is almost dovetailed in place. Good job, Sony. This is a very durable looking connector. And it looks like the back end of this is potted in something. Some sort of, looks like polyethylene almost. Right, well, either way, we can see the colors of the wires that are in here. You can see that we've got this red wire here, then orange, then yellow. Looks like we've got green and a blue further down over here. And over on this side, we've got a few more. Alright, so that's interesting. Now, we've got that end taken apart. Let's open up the case proper. And also, let's get some place to put these screws where they won't go sailing all over the workbench. There we go. Four screws, and that's it. This is probably a chrome passivated. Yeah, mild steel plate. It's magnetic. Interesting way that they made this. So first of all, this looks as though it was press formed in a die, and so they stamped this and stamped out these notches and then inserted these feet on top. Very clever way of keeping the feet in place. And there's more than 2 millimeters of rubber in all directions, so this is actually quite durable. This is a relatively high durometer. I'd say probably about 50 or 60 rubber, so really tough stuff. And the feet themselves are like, this is like 5 millimeters of rubber on here, so that'll last you a while. Now this is fun. That strain relief pattern, that's great. So these bosses on the inside here aren't actually for screws. You can tell because there's no place for screws for those on the outside here, but instead are just to wind the cable around. This is absolutely masterful construction. Then there's another strain relief right here. Let's see. We have a dead bug. Any entomologists, please contact me with an identification if you can. Put that in the art bin. Right, so we've got 5 wires that come in here, and this is also the reason why I wasn't getting any tones, is that as far as I can tell from this little, I'm guessing, transistor right here, this is actually an active system rather than just being a couple of relatively passive switches. Another interesting thing about this is that we've reached the end of the external screws. That means that everything from here on in is hooked in place, and everything is dependent on this little tab of probably easily fatigued metal that's twisted into place. So if I twist this back into place, there's this oddly shaped, almost washer around it. I'm guessing that if I twist that back in, then with judicious application of force, yep, I can get this come off of there. But that's not the only thing holding us back or holding it in place. We also have these 2 springs there providing counter tension here. There and there. And voila. So this is the foot pedal itself. It's comprised of a large amount of this looks to be 1.5 to 2 millimeter thick steel. We still have a couple of springs inside of this hinged backing plate here, which I'm guessing is to give you both further action, and also this, it seems, contacts the 2 outer switches here and here, and then there's a middle switch which is contacted by this pin right here. So by having those 3 separate switches where they are, this one can essentially, we know that that's the fast forward, so you can't fast forward while you're either starting and stopping or rewinding. This is kind of a mechanical or. And we have a block right here, literally a block of metal that sits underneath this ledge, and which prevents this from displacing too far in. This is fascinating engineering. There's also another pivot point right here that rides on this block of metal on the other end. Otherwise, this is definitely injection molded plastic, very 1970s, 1980s insofar as the coloration and the type of injection molding being done here. These do not feel as though they're loose. I wonder if those were actually cast into the part. So this one has some room there. No, I think these are actually wider at the bottom, so these were cast in the part, which also might make sense of why we have such large, what look like ejection pin sights all around. So that still have that. Either that or these were heated and placed in afterwards. I'm not certain which. Then around the edge of this, we also have a whole bunch of rubber because the entire front piece is actually rubberized. There's a rubber housing essentially that goes outside of here, and this is similarly thick to the feet that we saw a moment or two ago. But the interesting thing is this is even higher diameter, like 70 or 80. I'd almost say this is real. This stuff barely bends at all. So this is more protective than cushioning, and to also give you a good amount of friction when your foot hits this strike plate, so your shoes aren't sliding off. Somebody did a real bang-up job with this thing. Right, so if we assume that our red and our black are, let's see here, red goes up to the fast forward button, loops back around, comes into the transistor here. Black goes into this one and this one, so that might be a ground, which would leave these three as signal. Let's see here. So there's a voltage divider and a diode here and transistor. So this is interesting because I didn't think that this thing was going to give us back individual voltages per each one of these wires. I thought this was just going to be discrete control on each one. Well, either way. And on the inside there, that's a C1815. Let's look that up, shall we? C1815 transistor, NPN epitaxial. So I'm gonna guess from this that this is probably, I mean, this is roughly equivalent to a 2N2222, just with a different gain and saturation. Yep. And is our pinout standard? Yeah, emitter is on the left, collector in the middle, base on the right. Yep, so collector base voltage can be up to 50 volts. Remember that this was designed and built in a period of time when you'd have a lot of voltage sometimes moving into and out of devices just because the semiconductors had high threshold voltages. Things weren't necessarily all that reliable. Remember, even RS-232 was once plus and minus, I think, 15 and then 12 volts, and it's only recently that UARTs have even come down to like 5 volts or 3.3. So, yeah, you need to have some tolerance in there. This is good to know. Alright, and now, as a new segment on Take It Apart, we're going to put it back together, because it seems like either this might be eBayable or just possibly interesting to use in some other system. So let's see what we can do there. Alright, so first of all, I should make certain I have the washer back in place here, or whatever you'd call this. This was made in Japan, so we're going to try and figure out what the folks in Japan would do to put this together. I'm thinking that first of all these springs should probably be up and accessible, so that when we put this back on, you can shift those over to the holes that they reside in. So this sits on there. All right. Oh, I've just gotten the spring off entirely. All right. Use tweezers to try and get some traction on this problem. Although technically it's tension on this problem. Okay, there's one. Here comes the other. That wasn't as bad as I feared, which is good. Now we just twist this. This is back in place, that's good. And now this sits up on there. Get to cheat with the electric screwdriver. One of these. There we go. And then we need to get the boot back onto this connector, which slips back in rather nicely, although we've got to push these little fingers back in. Just put these two back in. Right, there's that one. And there's that one. Hey presto, there we go. Well, hope you liked that. That's it for today, so thanks for watching.